presented. I'm going to talk today a little bit about remote sensing tools that I had a chance to use as a hydrologist when I worked with the Alaska Pacific River Forecast Center, part of the Weather Service that really is what I guess collects and the information about river breakup during the spring and its propensity for flooding, gives a flood outlook and conveys a lot of information. So a lot of what I know about uh, ice breakup in an operational sense came from my time at NOAA, and many of my colleagues from the RFC are here today. I'm also going to present some material that I collected as a investigator for the University of Alaska Fairbanks, and that was supported by the State Department of Transportation. Let's see. So just as a teaser here, I first want to show you some imagery I collected from an uncrewed aerial system here at Peters Creek in Anchorage. And that was a site that Jeff Urbanis talked about yesterday that is characterized by development of anchor ice during freeze up, and this can lead to some freeze up ice jamming and flooding in this neighborhood just north of Anchorage. This is an orthomosaic, so it's a number of individual frames that have been then stitched together using software. But you can see, I took this image on November 4th in 2020, and you're looking at a nadir view here, but the ice is really up to the bottom of the bridge, and that is what creates some problems here. So a week later, I took this picture, and if I kind of go back and forth, you can see that there is some shelf ice that's separated then from the banks, and there was some snowfall. If you were looking at it obliquely, you would see that this is actually dropped in level relative to the bridge. And then I went back another week later, and things have changed again. Some more of that surface ice has dissipated, others has formed, and then you can see that anchor ice again. These are pretty low light conditions in November in Alaska, but I still think that the imagery shows some really nice information about what's going on. You can also see some like surface waves, and as uh, Chandler and Jeremy talked about yesterday, and Jeff himself as well, how dynamic and the slope of these streams makes a difference in the formation of that anchor ice. So that was a bit of a teaser. I just want to talk today about, I want to give some acknowledgements. I want to talk a little bit about NOAA's mission during breakup and ice jam flooding in Alaska. I'm going to show some satellite remote sensing tools for breakup ice jams and freeze up ice jams as well. Jeremy provided some nice background on Aufeis, but I want to give a little bit more that's Alaska specific. And then I'm going to show imagery from crewed and uncrewed aircraft and handheld and mounted cameras near the ground, and just talk a little bit about pros and cons of different strategies. So I want to acknowledge that since 2006, I've lived and worked throughout the state on traditional homelands of Alaska's Native people. I've had a lot of different sources of support for this work back when I was research faculty at the university. That support came from NOAA as well as Alaska DOT. I won't go into the details, but that information will be in this slide deck. I also want to point out thanks to Katya Kantar for pulling me into her peer-to-peer Department of State exchange project to Russia in 2015 to study comparative ice jam flooding mitigation and social science. It was a very cool project. My colleague Ed Plum was also on this trip, and he's in this picture. Katya is shown here on the left, and She actually did her PhD dissertation at UAF on the social science behind ice jam flooding in Alaska and Russia. Very interesting work. She's gone on in a policy career. And this photo was taken near Yakutsk in the World War II Lend-Lease monument that was shown in the lower right-hand corner in flood conditions, and we went there in the winter. So this is very interesting experience in talking with colleagues in both Eastern and Western Siberia about their mitigation strategies, their emergency management, et cetera. So happy to tell you more about that offline. All right, a little bit about what the Weather Service does in terms of operational management of ice jam flooding in Alaska. Um, so this is one of the products that the River Forecast Center puts out. I pulled an image from a year or two ago so that you could see some variability in this map, as opposed to it's all pretty frozen still at the moment, but our forecasters will update this every day during breakup. This map shows conditions along Alaska's major river reaches. And the river status then is provided as well as the warning status for different communities. And I think in recent years, we've really switched from using sort of the telephone to call different communities and some pilot reports from commercial operators. We really moved over to using satellite information to provide updates to this map every day. And then many of you probably are aware of the RFC's River Watch program, is where forecasters travel with the state of Alaska's emergency management group to different communities, primarily on the Yukon and Kuskokwim, to provide outreach to community members and hear from them what's going on, as well as this airborne reconnaissance. And there are some oblique photographs taken from cell phones and field cameras and such out the window of this plane, but primarily this is the forecasters are just using their own eyes to interpret what's going on the ground. They'll call those observations back to the office, and that information will also help update this map. Here's an example, and it may have been Jeremy yesterday who mentioned these VIIRS-based products. So this is a satellite product. VIIRS is an instrument that was originally flown on SWOMI and PP platform, and then has subsequently been on the both the GOES-R and the NOAA JPSS missions, and so this uses near infrared and optical bands to use a differencing technique and is then interpreted to show ice cover on larger rivers in Alaska. Here's a shot from 2019 on the Tanana, and you can see dark blue indicates pixels that are primarily open water, and the cyan color is ice in place. We also get actually a snow cover product out of this. And then an area like Delta Junction on the Delta River, you can see some red. That actually indicates an overflow condition where you have liquid water on top of ice in place. Those of you who know that area, it's very braided channel with a lot of gravel, and essentially that's really an off ice signal there. So interesting stuff. We get this imagery and this derived product about 6 times a day during the time of year when the sun's high enough to generate the, again, optically based product. Anyone can access this data at Real Earth on the web there. So that's one source, and that will show water out of bank as well. Another even newer remote sensing product is being generated by the National Water Center in Tuscaloosa. This is a synthetic aperture radar-based product, is in the microwave band, so it can see through clouds. It doesn't need optical channels. And here they're driving this from Sentinel-1, one of the European platforms, but it could be generated using a variety of different SAR sensors. And so here we're actually showing I believe this is a freeze up jam on the Kenai River at Big Eddy, is a notorious area for freeze up jams. And again, we have open water shown in dark blue. In this product, solid ice is shown in red. And this was then verified by reports there in Soldotna, Alaska. Very useful product. We don't have the same sampling frequency. We only get this about every 5 days, based on a tandem of actually the two different platforms flying here, Sentinel-1A and B. But that is a useful product for both breakup and freeze up for its spatial resolution. The VIIRS products are pixels are about 375 meters native resolution. This is more like 10 meters. So you can get at a much smaller river like the Kenai. The Sentinel, the optical sensors here from Sentinel are also have proved a real game changer for the River Forecast Center. Here, this is a picture of where the Aniak River is flowing into the Kuskokwim, a notorious jam spot that was mentioned yesterday. And the resolution of this imagery is just incredible and really shows that that tributary has opened up and can cause some problems if it's got a lot of flow before the Cusco there is opened up and let it flush through. So Sentinel-2, again, has a tandem A and B, and so that comes in, gets refreshed about every 5 days or so. So before the Sentinel optical imagery was available, this was a project I did when I was at the University of Alaska. I collaborated with the RFC folks and did some ortho imagery. I collected this from my own airplane with a downward looking Nikon camera. This is the Yukon River at Circle during breakup. And you can see the Circle Airport is that little airstrip in the middle. And then this has been overlaid onto some background Google Earth imagery. But this is how braided and variable the Yukon is at Circle. You can see there's some open channels and some in place, and the complexity is one of the things that leads to ice jam flooding at Circle. So on that same campaign, I'd gone out on May 3rd, starting at Dawson, and taken this imagery in the upper right-hand corner. In the lower left-hand corner, I went back 2 days later, and you can just see the change in the breakup front is relatively dynamic that year, in that there's a distinctive breakup front, and it's propagating, over the course of a couple days. So that was imagery then that I would process overnight. I could take about 1,000 pictures. I was flying about 7,000 feet right below sort of a little cloud deck. So pretty high to get kind of bank to bank on the Yukon, but with a level of detail that is really now pretty much comparable to that Sentinel optical imagery. Here is one of those same collections on the 3rd, and then we've overlaid that VIIRS product, which at that time, SWMI MPP had been launched, but the product wasn't yet being derived, and so it had been tested with MODIS as a proxy. And we were working with the algorithm developer, Dr. San-Mei Lee, and this optical data set then provided a really nice validation for for her satellite product. So then we wrote a grant together, and we actually got her out to up to Alaska, and she had never actually seen river ice. And I had a chance to fly her out to Eagle, which is another flood-prone community in Alaska. This was the ice jam that I had found actually the day before, where I was with my contract pilot and I could shoot some photos while he was flying the plane. And so this is at the Calico Bluff site that is very prone to ice jam flooding, again, due to those channel geomorphology in that area. And you can see that the sheets are in place and the water is backing up, and very interesting, and such a good experience for Dr. Lee to see that in person and really get a sense of the difference between snowmelt waters and flood waters as this jam was starting to back up into Eagle. Another thing I want to mention here, and I'll come back to this in a minute, are the remote field cameras. This is the one that's installed in Dawson, and the RFC relies heavily on this to watch for breakup in Dawson as the Klondike flushes out and starts to push water. And this is a really this fisheye view, very wide angle. It gets a fair amount of that community, but we don't really know what's going on upstream. Okay, so I do want to then kind of talk about another site and hone in on off ice. It's sort of a different problem in terms of imaging than the surface ice. And if you want to know more, there is at this point a draft report on that I did for DOT on testing these different imaging technologies for the off ice problem as it interacts with infrastructure here in Alaska. So as Jeremy mentioned yesterday, uh, there's not a lot that we know about off ice, globally, but Alaska in particular. There's really just a handful of papers. One of the more recent ones by Tamlin Pavelski and one of his colleagues. And I think this picture is from the Hula Hula. You can see some really thick off ice has been drained here. This is the focus has really been in the high Arctic for a lot of these off-ice studies, and that when he says in this paper that these off-ice fields are disappearing according to analysis of the Landsat record, I think that's really limited to that particular geography. Again, I had some information about the Jarvis Creek study that Jeremy mentioned. I won't repeat that, but there are a couple things that I wanted to point out that came out of this DOT study I did, that we do have evidence that structures that block the flow of ice and water may actually help form off ice. And so while these natural fields in the high Arctic might be disappearing, I have some reasons to think that that they may become more of a problem actually in other parts of Alaska. And of course, we saw this uh, from the other Jeff yesterday, this pretty impressive flooding up on the Sag River in 2015 that certainly interacted with the infrastructure of the road itself. This figure I pulled from this older publication, and it is in a somewhat different terrain. The carbonate formations of the northern Yukon, different geology than Alaska. But what is shown here is just the interactions between talix and groundwater that feeds off-ice fields. Of course, as permafrost degrades in the far north of Alaska, you get more subsurface storage, more subsurface connectivity that may lead to less pressure on off ice. On the other hand, that could be balanced by changes in the hydrologic cycle, which is something I've published a number of papers about, the intensification of the water cycle and the likelihood that that as the climate warms, we're going to see more moisture transport into Alaska, particularly during the cold season. And so that could put more pressure on the just having more available moisture that percolates into the groundwater and could put pressure in these off-ice systems. So something to think about. We don't know very much about groundwater in Alaska. Uh, this Caligari paper from 2013 is one that does go into some detail and its interaction with permafrost. We have these different provinces for groundwater in Alaska. Um, the site I'm going to talk about here is kind of in that pink zone, the South Central province. And of course, this is the one of the more recent maps, Jorgensen 2008, that shows the distribution of permafrost in the state and whether it's continuous or not. Even in this continuous zone, we do know there's groundwater and it does have some level of connectivity in the subsurface. Of course, the slope of mountains also has an impact on the propensity towards off ice, and the soils. We have both slope and soils shown in this plot. So if there's a lot of unconsolidated material, it effectively, more water can percolate through those systems and congregate in the subsurface, again, potentially putting pressure on those rivers that have a propensity to develop off ice. So a little bit about the DOT study. We focused on uncrewed systems, aircraft data, and also handheld field cameras. And just the logistics were set up for these different field points. And so there's kind of a round robin through the state for 4 seasons. Collected data on the parks, and then kind of in this eastern interior zone. And because this is throughout the winter, we did focus on kind of our fuel logistics and what could be flown in a day with really short light, short amount of light in the winter that could be done in one day. So then a couple years later, we started doing this with uncrewed systems, and some of that picked up the same sites here. So I just want to show one site in detail. This is the Jack River. As I mentioned, this is in the Alaska range. And it, I think, illustrates a lot of these points that I want to bring up, and it might be discussed in the panel here. So the Jack originates in the mountains, and then it flows into the Nenana. And the Nenana is one of these oddballs that actually flows north all the way through the Alaska range and then joins the Tanana. So there's a lot of topography in this system. Here is a picture from satellite that is just the imagery that's available in Google Earth. This imagery was collected in 2017. And so you see the Jack River crossing in the middle. You see where the channel is. But you can see, holy moly, there are a lot of things going on with hydrology interacting with infrastructure in this satellite image. You can see that the road is impounding water. And so, as we think about what's going on at the site, there are clearly some historic material sites that were used for gravel to build the road. There's disturbance then in the geology. These look like very unconsolidated soils, very gravelly. And then you also see a lack of vegetation where that was, part in natural due to its location, and then probably heavily disturbed by the construction in this area. So I didn't take this image, but it tells a lot about the images that I'm going to show here. So here's one of the photos I took from my aircraft that same year, the month before. and the downstream is to the left. And if you look closely in this crossing, you can see some lines on the pavement that indicate where the bridge piers are, and then you can see some overflow ice that's bubbling out basically exactly from where these piers are. Just to give you a sense of scale, this bridge is about 180 feet across. And to me, this was just a real indication from an aerial that you did have. The bridge is blocking water, forcing it to upwell and helping generate then this overflow formation. Some other pictures in prior years in 2016. This is what it looked like during freeze up. You can see where the channel is. But a year later in 2017, the channel as it's freezing up is in a different place. So there's also some changes in the geomorphology here happening, and maybe the thermal balance as to where that opening is in the ice. Don't see as much in the early spring, although it is enough to generate, again, these are orthomosaics that have been pulled together using the structure for motion technique. And so you can generate a relative digital surface model from this. And even though the spring scenes look like a blank white, you actually see there's a lot going on. You can see where the channels are. You can see where snow machines have traveled over the winter. Some detail here. So then with UAS, the question was, can we get at what's going on under the bridge? And then what are the pros and cons of doing this with handheld field cameras as well? So this picture was taken by my employee, Tim Smith, in 2020. And you can see that breakup has not begun, but there's some other interesting things happening under the bridge. The bridge is intercepting snow. There's probably some alien dust transport kind of in and around this pier. These are the kind of things you can see with a drone in that level of detail. This is the ortho from the drone. Looks pretty much just like the airplane. But here's the oblique that you could take from the drone that's a little bit harder to get for a bridge that's this small, or be harder to get from the crewed aircraft. Again, you can see the bridge itself is intercepting snow. There's basically a different energy balance and going on with the ice right under the bridge as well. Here's the view you get from a handheld field camera. So this is a GoPro. I believe this is looking upstream. So this would be difficult to do, photogrammetry on, given the fisheye lens. But there's some also really useful things you can see. And this is basically the smoking gun for this site, in that you see there are holes in the ice all the way to the left part of the screen and to the right. So right along where these piers are, you see upwelling. And in fact, we saw the upwelling leading to these cracks in the ice. And in this image on April 22nd, so right as breakup's beginning, you get some very dynamic upwelling from what looks to me like groundwater. This is on the upstream side of the pier. So that is basically what I wanted to show you today, and happy to tell you more about these data sets or reports, et cetera. Feel free to contact me.
Does anyone have any questions for Joe?